Welcome back. All right, so now let's find the perimeter of the rectangle. All right, so to do that, notice we're missing a side. All right, I'm just going to call this side W. Right. In a rectangle, the opposite sides are congruent. So this side here would be 8 inches as well. But we don't know those two widths, right? Those two sides. But notice that the rectangle has right angles, which means that if we draw a diagonal from one corner to the other, we have created a right triangle. And we know we can use Pythagorean theorem to solve for missing sides in a right triangle. All right, so step 1, we're going to use Pythagorean theorem to solve for W. Right, so we have, so this is a leg, and 8 is a leg, and 10 is opposite the right angle, so that is the hypotenuse. So we have 10 squared equals 8 squared plus W squared. 10 squared is 100, 8 squared is 64. If we subtract 64 from both sides, we have 36 equals W squared. We're going to take the square root of both sides. And remember, we're only taking the positive square root because this is measurement, and measurement has to be positive. 36 is a perfect square. That would be 6. If we were just solving any old quadratic equation, we'd have two answers, 6 and negative 6. Because negative 6 cannot be a measurement of a side of a rectangle, we only want the 6. Now that we found the missing side, we can find the perimeter. And we'll just use the formula for perimeter. All right, so since the rectangle has two pairs of congruent sides, to find the perimeter, we're just going to add up 2 lengths and 2 widths, right? The 2 different side measurements we have. All right, it doesn't matter whose length and whose width. Let's make 8, I guess, length, and since I called the other side W, that'll be width. So the perimeter is going to be 2 times 8 plus 2 times 6, or 16 plus 12, which is 28 inches. So there we go. We found the perimeter of the rectangle thanks to Pythagorean theorem. Let's solve another problem. All right, so now we're going to find the perimeter of the square. All right, well, so the square has some things in common with the rectangle. It does have all right angles, which means that the diagonal of a square is going to divide the square into 2 right triangles. But they're not going to be just any right triangles. No, they're going to be isosceles right triangles, because we know that a square has all sides congruent. So before finding the perimeter of the square, we need to first find the length of each side. And in a square, all sides are congruent. So if I call this side S, this side is also S. Right? Which means we only need the hypotenuse to be able to solve for this one. Right? We can solve for both sides since they're the same. So step 1, we're going to use Pythagorean theorem to solve for S. So we have, this is, of course, is a leg. That's the 2 legs in our isosceles right triangle, and 18 is the hypotenuse. So we have 18 squared equals S squared plus S squared. S squared plus S squared is just 2S squared. Let's square the 18. 18 squared is 324. All right, now before we take a square root, we need to isolate the S. So we're going to divide both sides by 2. All right, so 324 divided by 2 is going to be 162. So now we'll take the square root of both sides. And again, we only want the positive. All right, and so the square root of 162 is S. But I know that that will be simplified. Well, I know at least it's not a prime number because it's even. Let's see if it can be simplified. It's divisible by 2 because it's an even number, right? Well, 162 divided by 2 is 81. Well, 81 is 9 times 9. That's a perfect square. So guess what? 1 9 comes out. 1 9 goes away. but the 2 didn't have a buddy, so it stays in radical prison. So S here is equal to 9 square roots of 2. That's the side. Must be a glitch there. That's the side of the square. Look at that. That's a horrible looking rectangle and I boxed my S in. All right, so now let's find the perimeter. So to find the perimeter, we're just going to use a formula. The perimeter of the square, since all the sides are the same, are just 4 times the side measurement. All right, so that's our step 2. Find perimeter. So P equals 4 times 9 square roots of 2. If you're multiplying a number by a radical, if it's outside, if this number is not in the radical, 4 is not in the radical, we multiply number not in the radical by number not in the radical. So 4 times 9 square roots of 2 is 36 square roots of 2. Radicals get multiplied by radicals. Numbers outside radicals get multiplied by numbers outside radicals. So the perimeter here is the exact perimeter is 36 square roots of 2 centimeters. Right? And another problem is done. Let's do one more. Let's find the area of the square, area of the triangle. So the base of the triangle is given, but we need to find the height of the triangle. Now, the height of the triangle is always perpendicular to the base. So guess what? This is going to be a right triangle. Now, since this is an isosceles right triangle, the altitude is going to divide the base into 2 congruent segments. So that means if the whole base is 10, the base of the triangle that's created by the altitude is going to be 5 feet. That means that we now have 2 sides of our right triangle, and we just need to solve for the 3rd side. I actually have this on the next page, so let's go over this problem. All right, and this is in your notes, but it's on the first page, just to make things interesting. It's on the first page, because that's where it fit. So by definition, the altitude or height of an isosceles triangle is the perpendicular bisector of the base. So it is going to divide that base there into, when it creates the 2 triangles, each of those 2 new triangles is going to have a base now of 5 feet. Right? So we now know that this measurement here is 5 feet. So we have 2 sides of our right triangle. I already wrote in the answer there. All right, so 5 squared plus h squared equals 13 squared. 5 squared is 25. 13 squared is 169. Subtract 25 from both sides. H squared is 144. We take the square root, but we only want the principal root. We only want the positive one because this is a measurement. And so the height here of the triangle is 12. To find the area of a triangle, so the area of a rectangle is length times width. You can create 2 triangles out of a rectangle. So the area formula for a triangle is 1/2 length times width, or base times height. Length, width, base, height, really, they mean the same thing. Right? Whether I call that the length or the base, whether I call something the height, the altitude, right, the width, right, it means the same thing. All right, so the area is going to be 1/2 base times height. The base of the triangle, right, is the base and the height are the 2 perpendicular measurements. So now we don't want to find the area of just the little triangle. We want to find the area of the whole big triangle, the isosceles triangle. So its original base was 10. Right? And now we used Pythagorean theorem to find that the altitude was 12. So now we have 1/2 times 10 times 12, and that's going to be half of 120, or 60 feet squared. So linear measurement is in units, and area is in units squared. And so here we go. We can use Pythagorean theorem to find lots of missing measurements if we can, out of figures that aren't right triangles, so long as we can create right triangles. Right? And that's the last one for this podcast. Thanks for watching. Bye for now.